Hi there.
Good day.
Hello.
Encrypting the mempool. Hi everyone. Take a couple minutes for folks to arrive.
GM.
Hey Yakum.
Hey, hey.
Oh,
Hey Luis. Ben, what's good, buddy?
Hey.
Admin. That's impressive. How do I get root access?
I'm not logged in. This is Loring from Shutter.
Oh, hey Lori. All right. Nice. Let's see. Let's post the agenda here so folks can get to it. Which I closed. Oh no. Why would I do that? This is meeting number 1 because we already had meeting 0. Agenda is here in the chat. Thanks for joining, y'all. We can get started. Couple of things to discuss. You probably heard already, EIP 8105 has been withdrawn. This was the Universal Encrypted Enshrined Mempool design. It has been withdrawn with the intent of improving Lucid to cover what it provides. So the authors felt that Lucid got them where they needed to go, and we've withdrawn that one, and we're pursuing with the Lucid design. Speaking of the Lucid design, there's an EIP that just got published this morning by our own Anders Ellison. Hi Anders, welcome. This is the link to the pull request for the EIP.
Hi, let me share the link.
Yes, sir. You got it. Just put it in the chat. So this will, it will look a little bit different than the ETH research post because this is more of an engineering document. You're all familiar with EIPs, so you're going to have a lot more specifics in here. Further discussion should be directed to the pull request or asynchronously, but if you have ideas for improvements to it, please, they are welcome. Okay, with that, I think we kind of open up the floor here to questions, comments, and concerns. I think one of the things that I wanted to talk about was, and maybe we don't have to start with this one if there's something else folks would rather start with, but beacon chain RPC APIs. The design as it stands right now needs to kind of be able to listen for events on the beacon chain and send messages to the beacon chain from the wallet. And that's kind of a new thing. So who has thoughts on that? I know RPC providers do provide the beacon chain RPCs. So they're out there. They're usable. But what do folks think about that? correct, Yakum. 8105 is being withdrawn, and Lucid is going to take its place. No thoughts on beacon chain RPCs? I'm not a CL developer, but I was fine with it. Okay.
Is there a lot to discuss there? I guess if we need new endpoints, then I guess we have to add them. The fact that there's now an EL and a CL API that has to be used from wallets, it's kind of annoying, but it is what it is.
So,
I mean, it's
yes,
optional. Is that correct? So you don't have, not everything is necessarily forced to be encrypted.
correct. Oh, yes, correct. This entire feature is optional. That's correct. So it would be an update to an existing RPC method and the addition of a new one. Okay, so there'd be a new one for actually releasing the key and then a new event type to listen for. So the beacon chain RPC API already has like a WebSocket type thing where you can listen for events with filter. This would be adding support for, hey, your transaction has been included, you are safe to reveal the key. So a new event. You can find this in the section called Beacon Chain RPC API Changes in the EIP. Because is asking for a 5-minute pitch of Lucid and another 5 minutes for its biggest issues and pitfalls. I can see CL RPC as a definitive nuisance. Would you mind saying more as definitive nuisance?
Well, it's something that you said it's not specified yet, so something that we would have to go and do, right? Just for it.
I mean, the overall beacon API is specified. Is that what you're referring to?
No, sorry, I had to misunderstood something then.
Okay, yeah, it would be at one new method that needs to be specified and updates to an existing method. Okay.
Yeah, maybe to ask because this PR dropped 40 minutes ago.
Yeah.
And Lucas is also saying like, yeah, can we have like a pitch of this and maybe also like some changes because yeah, I could not read the PR in 1 minute or 40 minutes. Yeah.
Sure. Sure. So, Anders, would you like to do this one, or do you want me to go for it? You're on mute. Okay. Well, if Anders, I guess I'll go. So, yeah, the pitch for Lucid essentially is a 2-slot design where users reveal a ticket essentially that claims a portion of the block space, where they say, all right, I'm going to be sending a transaction, it's currently encrypted, and here's my ticket that kind of reserves it in the next block. All right? So you can look at this as not really all that encrypted, it's like a little encrypted for a slot. So that way that the transactions can be populated across the mempool, they can't really be inspected, they can't be acted on, and then once the transaction is included via its ticket, the wallets will then reveal their keys. Keys will be used by the builders to decrypt and build their block in the order that they paid for with their top of block fee. So that's kind of the high level elevator pitch. As far as pitfalls, I think, it only prevents front running. It really is like I said, it's more of a transaction ordering fix. So you could look at that as a pitfall. There's currently a debate ongoing right now in the Encrypted Mempool's Discord channel on R&D as to how it impacts backrunning. Like if we consider backrunning to be good MEV, this may make it less efficient because what you would be backrunning would essentially be the entire top of block. Like you wouldn't actually be able to insert transactions into the encrypted, the lucid block space, if we think of it as its own block space, is inviolable, right? Those are already ordered, so even if they are revealed in plain text, you can't insert stuff in there. You can only backrun the result of the entire top of block. What are some other pitfalls and shortcomings that folks think should be brought to light? Anders, Julian, anything you want to add? Yes, this one slot delay is considered, your prices are going to be stale, right? Ish. So you had a non-deterministic timing in slot n, and now you're going to go to slot n plus 1, and you're going to be behind based on your top of block fee. So if you don't bid the highest top of block fee, everybody else that did outbid you is going to go in front of you. So yes, your prices will decay a little bit. Any overhead on the network side? With regard to bandwidth increases, there's new traffic. It's small traffic. The keys are small, the tickets are small, but it would be new traffic and some potentially new topics on the CL P2P network. If the encryption key is not revealed, Anders, correct me if I'm wrong here, but...
I can talk about it a little, yeah.
Okay,
So
good.
if you do not reveal your encryption key, we have in this latest version instituted a penalty. So what happens is that when you pay for the encrypted transaction, you pay a top of block fee to be, and the commitment that pays the highest top of block fee goes the first. And if you decrypt your transaction such that you reveal the transactions that matches the commitment in the ticket, then you are returned a proportion of this top of block fee. And currently it's set so that you are returned 63 out of 64. So it's like you are returned 98% of what you paid or something like this for actually decrypting. And if you do not decrypt, then you lose out on that top of block fee that you paid. You can set the top of block fee to 0 such that you do not have to pay any penalty for not revealing, but then you will end up lost within top of block. And you may not be included also, because if someone else pays higher, then yeah, they would probably go before you.
Thank you, Anders.
And I can mention one thing more, is that if you do not reveal, you also there's nothing like we don't waste the block space, because then the builder of the next block simply ignores that, and so it doesn't count against the gas limit of the block.
Maybe this would be a good time. Anders, could you elaborate on how we know a key was not revealed? I think that might be a mechanic that folks could learn a lot from.
How we know a key is, so the current implementation has a PTC vote on which keys that are revealed, and these PTC votes are observed, and the builder must adhere to whether the PTC voted that the keys were revealed or not. And so if a key was revealed, if the decryptor address that was specified in the ticket released a key that decrypted the transaction such that you get something that matches the reveal commitment in the ticket.
Thank you. Mark has a question in the chat. If we do this in Hagoda and we also do frames, how do the proposals interact? We haven't really looked into that too deeply because having 3 headliners and a hard fork would be a little wild. Hagoda is kind of either frames or Lucid or SZ. Do encrypted transactions go into frames?
I can mention one thing. I cannot answer that question either because I haven't looked into it, but I can talk about the interaction with Fossil. So the current specification is that we should interact with Fossil such that the inclusion list should be able to include these sealed transactions. But this is not a requirement because you get quite a lot of censorship resistance even without having this. This is something that can be added later, because even without adding it so that you put the transactions into the inclusion list, you still have this property that the sender is hidden and the content is hidden. So like a lot of the rationale for censoring a transaction isn't there anymore.
Great.
Well, that depends how long the transaction sits in the transaction pool, actually. Because you're thinking about censorship, but there's also non-disclosure, right? Because you might want a non-censored transaction that's actually going to be quite long-lived in the transaction pool.
I don't understand the question.
Well, I think the thing is you end up needing both, right? Because I think what encryption is doing is protecting you from the inclusion order issue, but also the information leakage issue. And the information leakage issue is actually around the mempool, not the block building.
Yeah, but why would so my point would be like this: why do someone censor a transaction? Perhaps because it accesses a contract that you don't want it to access, or it does something that you don't like, or something like this. But in the case that you don't know anything about what the transaction is going to do, it's very hard to find an economic rationale for censoring just a random transaction from a new account. And the only reason you would have for actually like the only mechanism for censorship in this case that is reasonable is if you, for example, if you cannot blacklist one address because you can hide the sender, but you can do some sort of whitelisting where, okay, I'm as a builder only accepting transactions from these addresses. But in this case, it's very difficult to be profitable as a builder. So we would presume that this would not happen. And so we uphold censorship even quite strongly, even without going and using Fossil.
By the way, that's also why in EIP 8105 there was not the case that it went through via Fossil, but rather just be a normal transaction type. So just want to underline that point.
All right, cool.
All right. We've got about 10 minutes left. Happy to entertain more questions from the floor if there are any. Everybody's probably reading the EIP. Is anybody here representing builders or searchers? I'd love to hear some input from folks that coming at it from that perspective. Okay. I have on the agenda to talk about bundling and ciphertext encapsulation. Ciphertext encapsulation is kind of a new thing that we're adding. We're actually suggesting some symmetric encryption that should be used for the encrypted transaction. And you know, that's a new thing. It's going to use AEAD as described in RFC 9180. Which is a somewhat standardized ciphertext encapsulation format. So we'll have, you know, suggestions on how to structure the data and how it should be used. There is also, however, header bytes and extension capabilities. So while our suggestions right now are using symmetric cryptography and envelopes that are defined, there's nothing that prevents us from extending or creating entirely new ciphertext encapsulations there. I know that's a major concern for all of us as we look at our post-quantum future. And so with that regard, the encryption there is abstract. Okay. And then last thing is the notion of bundling. Anders, where did we leave off on bundling with this, not final, but most recent draft of the EIP?
Yeah, so we include bundling because yeah, it felt like it was an important feature to have. So you can bundle many different. The crypto can bundle many different of these sealed transactions into one singular commitment. And this is useful because for various reasons. One reason is that you release just one key message for all the transactions, and you can do two different ways. You can release the key message for bundles. You can either release one key for each transaction to be included, or one key for all the transactions in the bundle, depending on your encryption scheme. If you're a threshold encryption, for example, you will use one key and target a specific slot for your transactions likely.
Let's see. Lucas likes the explosion of transaction types. Do you have any ideas on how to avoid it?
So one idea is probably frame transactions to some extent. Other idea is kind of wrapping transactions with adding to them some kind of additional functionality, right? So one transaction type wraps the another and adds some functionality to it, right? Those are two things that come to my mind. because you can
Why
you
do you,
can.
can you elaborate on why you dislike the explosion of transaction types? By my count, we're up to like 5.
Okay. Okay, because we're going in a way I already I think mentioned it on ACDC. We're going in a way that we have it's like an inheritance hierarchy, right? So if we want to add some new transaction with some new functionality and it needs to be encrypted, now we cannot kind of how do we do that, right? In some way, and we add more and more and more and more and more. Instead of, for example, we could do composition.
Oh, these are composed. You can stick any type of transaction inside this encryption envelope.
Uh, envelope signer, well, no, that's in
Sounds like blob transactions. Yeah. Are we allowing decrypted and encrypted transactions at the same time? Yep, we sure are. And it does make sense because we want it to be an optional feature that folks use.
But would that not make like a way of escaping this feature? In a sense, like people could maybe like censor private transactions going forward and only run the normal ones.
So, Fossil protects against that. It's kind of why we refer to like the holy trinity of privacy features for Ethereum, right? Proposer builder separation, Fossil, encrypting the mempool. They all kind of lean on each other and provide different aspects in one happy little system.
Yeah, it seems likely that you need all three because in practice, if you're a regulated builder, you might well end up having a regulator saying, don't include, this encryption and privacy thing is like a big red flag, which is why I think if you're going to do this, you end up needing Fossil, which it's not a technical thing, it's a legal thing, right?
Mm-hmm.
What are the disadvantages of making everything encrypted from day one?
So, right. So we reserve, I think it's 1/8 of the block space for lucid types of transactions. And Anders, stop me if you prefer to speak to this. But if you allow the entire block to be encrypted, you kind of take us back to the bad old days of priority gas auctions, right? Like
There's one specific reason why we never want to make more than half of the block in these transaction types, and it's because we want to be able to, in the case that the payload is not revealed, we want to catch up, and that's why we want to allow twice as many transactions in the next payload. So we want to have a cap at the half the SCs.
Right, and that's for payload withholding, not necessarily key withholding. Got it. Okay. Well, we're at why is there a reserve space rather than some kind of gas auction mechanism? I mean, I didn't explore that design space. Did you, Anders? Happy to, to follow up async, Lucas, with that. I just want to be mindful of people's time. I believe we're at time. We only had oh no, we have an hour. My bad. My bad. So does that answer your question, Lucas? Andrew's response in chat? Aye.
I have a additional question. If I not sure if I understood it correctly, but post it in the chat.
Okay.
I don't quite understand your question in the chat. You have to.
Okay, so what does it mean that you have reserved? What does it mean? 1/8.
Maybe I said it wrong sometime, or that is reserved. I think it's probably not what we want to frame it as. What we can say is that it's the maximum. So you can use at the maximum 1/8 of the block's gas for these sealed transactions in the first. But we can expand it up to half.
And if there are more of those transactions, then part of them are ignored? What happened?
They would just be delayed till subsequent blocks.
It's just the same as always. It's the same as if now there are more than twice. If there's now more than the block fits, it's just the same mechanism. It doesn't change.
Okay, but even if they pay more than the other transactions that fit into the block, they still have to wait because of that limit.
Yeah, but unless they are, I mean, you have the inclusion lists as well that factor into this decision. But yeah, if you fill the block and the builder is free to decide, then the builder is free to decide if they wants to include them or not.
So where did you get to the one? Sorry, where did you get? Yeah, where did you get to the 1/8?
I framed it a little bit weird there because I shouldn't say it like that, because when you are a builder, you have already so we set the setting was 1/8. So when you are a builder, you have the committed transactions to your block already, and so it can be at most of this 1/8 of these transactions that you have to include, which are these sealed transactions that have now been decrypted and will be executed first on top of your block. And so those are given upfront. And then you have 7/8 of the block for your own transactions. And you also commit to tickets for the next block. But those 1/8 have already been paid for beforehand.
Do we have a block validity rule that checks for that? That would be kind of probably something that we should add, yeah? Like, you know what the block limits, you know what the gas limit's going to be in the next block. And so you should probably not try to include more tickets in the n-1 block than you're going to have room for in 1/8 of the next block, yeah?
Yeah, so you can at most include 1/8 of you can at most include tickets that pay for and consume 1/8 of the gas of the next block.
Okay. Okay, well, we got time to kill. If folks have more questions, throw them on out there. If not, we are at the end of the agenda. sounds like it's time to wrap it. Thanks, everybody. You can find us on Discord on the R&D channel in the Encrypted Mempools subchannel. Please keep the conversation going. Please reach out to any friends that you have in the MEV ecosphere. Right? If you know builders, you know searchers, we'd love to get their opinions on some of this stuff to try and figure out, other perspectives that we can look at the problem from. So thanks everyone, as always. And wallets too, yes, 100%, please. Wallets need to use this. So we need to make sure that we are hearing them. Brad, feel free to reach out to me, Julian, or Anders with any concerns. Thanks, everyone.
Thank you, Justin.
You got it.
Okay, thanks.
Thank you.
Thank you. Bye-bye.